Hello and welcome to the next video of section 3, Enemies. In the previous video we've learned about death and particles. In this video we'll learn about enemies. The next step is to create something for the player to shoot and destroy, which can also destroy us, namely enemy characters. These take the form of roaming spaceships that will be spawned into the scene at regular intervals and will follow the player, drawing nearer and nearer. Essentially, each enemy represents a complex of multiple behaviours working together, and these should be implemented as separate scripts. Let's consider them each in turn. Health. Each enemy supports health functionality. They begin the scene with a specified amount of health and will be destroyed when that health falls below 0. We already have a health script created to handle this behaviour. Movement. Each enemy will constantly be in motion, travelling in a straight line along a forward trajectory. That is, each enemy will continually travel forward in the direction it's looking. Turning. Each enemy will rotate and turn towards the player even when the player moves. This ensures that the enemy always faces the player, and in combination with the movement functionality will always be travelling toward the player. Scoring. Each enemy rewards the player with a score value when destroyed. Thus, the death of an enemy will increase the player's score. Damage. Each enemy causes damage to the player on collision. Enemies cannot shoot, but will harm the player on proximity. Now that we've identified the range of behaviours applicable to an enemy, let's create an enemy in the scene. We'll make one specific enemy, create a prefab from that, and use it as the basis to instantiate many enemies. Start by selecting the player character in the scene and duplicate the object with Ctrl and D, or select Edit Duplicate from the application menu. This initially creates a second player. Rename the object to Enemy and ensure that it's not tagged as Player, as there should be one and only one object in the scene with the player tag, namely the real player. In addition, temporarily disable the Player Game object, allowing us to focus more clearly on the enemy object in the Scene tab. Select the Sprite Child object of the duplicated enemy, and from the Object Inspector, click on the Sprite field of the Sprite Renderer component to pick the new sprite. Pick one of the darker Imperial ships for the enemy character, and the sprite will update for the object in the viewport. After changing the sprite to an enemy character, you may need to adjust the rotation values to align the sprite to the parent forward vector, ensuring that the sprite is looking in the same direction as the forward vector. Now, select the parent object for the enemy and remove the rigid body, player controller and bounds lock components, but keep the health components as the enemy should support health. In addition, feel free to resize the Capsule Collider component to better approximate the enemy object. Let's start coding the enemy, focusing on movement. Specifically, the enemy should continually move in the forward direction at a specified speed. To achieve this, create a new script called mover.cs. This should be attached to the enemy object. The mover script moves an object at a specified speed, max speed per second, along its forward vector. To do this, it uses the transform component. The update function is responsible for updating the position of the object. In short, it multiplies the forward vector by the object speed and adds this to its existing position to move the object further along its line of sight. The time.delta time value is used to make the motion frame rate independent, moving the object per second as opposed to per frame. More information on delta time can be found in the online Unity documentation at this site. Press play on the toolbar to test run your code. It's always good practice to frequently test code like this. Your enemy may move too slow or too fast. If so, stop playback to exit game mode and select the enemy in the scene. From the Object Inspector, adjust the max speed value of the mover component. In addition to moving in a straight line, the enemy should also continually turn to face the player wherever they move. To achieve this, we'll need another script file that works similarly to the player controller script. While the player turns to face the cursor, the enemy turns to face the player. This functionality should be encoded in a new script called objface.cs. This script should be attached to the enemy. The OBJ face script will always rotate an object so that its forward vector points towards a destination point in the scene. In the awake event, the findGameObject tag function is called to retrieve a reference to the one and only object in the scene tagged as a player, which should be the player spaceship. The player represents the default lookat destination for an enemy object. The update function is called automatically once per frame and will generate a displacement vector from the object location to the destination location, and this represents the direction in which the object should be looking. The CoreToNion.lookRotation function accepts a direction vector and will rotate an object to align the forward vector with the supplied direction. This keeps the object looking towards the destination. More information on look rotation can be found at the online Unity documentation at this site. This is looking excellent. However, before testing this code, make sure that the player object in the scene is tagged as player, is enabled, and the enemy is offset away from the player. Be sure to enable the Follow Player checkbox from the OBJ Face component in the Object Inspector. When you do this, the enemy will always turn to face the player. Now, if and when the enemy finally collides with the player, it should deal out damage and potentially kill the player. To achieve this, a collision between the enemy and player must be detected. Let's start by configuring the enemy. Select the enemy object and from the Object Inspector, enable the isTrigger checkbox in the Capsule Collider component. This changes the Capsule Collider component to allow a true intersection between player and enemy and prevent Unity from blocking the collision. Next, we'll create a script that detects collisions and will continually deal out damage to the player as and when they occur, and for as long as the collision state remains. Refer to this code, proxydamage.cs, which should be attached to the enemy character. The proxy damage script should be attached to an enemy character and it will deal out damage to any colliding object with a health component. The onTriggerStay event is called once every frame for as long as an intersection state persists. During this function, the health points value of the health component is reduced by the damage rate, which is measured as damage per second. After attaching the proxy damage script to an enemy, use the Object Inspector to set the damage rate of the proxy damage component. This represents how much health should be reduced on the player per second during a collision. For a challenge, I've set the value to 100 health points. Now let's give things a test run. Press play on the toolbar and attempt a collision between the player and enemy. After 1 second, the player should be destroyed. Things are coming along well, however, we'll need more than one enemy to make things challenging. In the next video, we'll learn about enemy spawning.